This is Sean O'Neill CA3 Games programming. I'm just demoing my code here. It's very similar to CA1 on CA2. As you can see, I've added a streets option as number 4 and number 6 as a save option. For the streets option, you just get to explore streets, which implements the random enemies functions. So there's random encounters depending on where you go. You can choose whether or not you want to go further into the streets after seeing the introduction here. So I'm going to say yes. And then you get another option as to which way you want to go when you come to a crossroads. So if I say left, now I've got the bad luck option. My luck wasn't high enough, so I got robbed. But since I don't have any gold on me either, then instead of getting robbed, I get stabbed in the thigh. I then return here, can go back into the streets if I want, and I'll go straight ahead this time. I come to a dead end and my luck wasn't high enough again, so I'm getting mugged. I have the options here whether or not to fight or run, so I'll say fight, and I lost the fight, so I lose 30 HP. Then I come back here. The save option isn't implemented yet as it wasn't working correctly, so it does nothing, it just loops you back around to here. And I'll go to the streets again and see if I can get a good luck option. I failed that time. And I failed that time also, which caused me to die, so the game exited in a game over. So I'll just demo the code. Well, I'll just have to show you through the code. This is where the streets starts, and here you have the luck scenario. So if your luck, which is your level multiplied by your dexterity, minus a random number between 0 and 100, then you make your way through the streets, no bother. You gain experience from it, so that's beneficial to the player. So it's not always bad to go down the streets. However, if your luck isn't high enough, then you get mugged by the little boy. If you don't have any gold, or you have less than 0, which is impossible, so pretty much if you don't have any gold, then he stabs you in the thigh. You take damage, which doesn't heal afterwards, so it actually counts. It makes a difference getting stabbed here. If you, as I did, if you just haphazardly run through the streets and repeatedly get mugged, then you will die. If you want to heal, you can go back to the arena, and that's where you heal. Now, because of the scenario with the boy, you actually get an item in your inventory, which is a dirty shirt, when you're done with that scenario. And if you have enough money, then he robs you and you lose 10 coins. In the other scenario in the streets, you can, if your luck is high enough, you arrive there when the thief is away, so you actually get to take some coins back. You get 15 coins back into your coin purse. However, if your luck is low, like too low, then he mugs you. Then you get the fight or run option. If your strength is higher than his strength, then you ready your option and you ready your weapon and you fight him. Then you win. And if your strength isn't higher than his strength, however, you lose and you take 30 damage. If you try to run, you either flee successfully, which is your dexterity, and a random number if it's higher than his dexterity. But if you attempt to flee and you fail, you die instantly and get a game over. It's a bit harsh, but I think it just displays the concept nicely. that's pretty much all that was added in main app. In function, I have the save implemented. It wasn't working perfectly, so that's why I have it commented out here, and that's also why it's commented out in the actual game and the main app, because it wasn't saving the character correctly. In the world, I've added to the build world function, as it wasn't working last time. So I've added extra bits, extra COUts to try and debug it, so I can read in what's happening and when. And then I added the find exits function, which is used in the build world function to find how many exits that particular room has. So it builds it room by room. It'll build the first room, and if it has 3 exits, then it will load those rooms next. And it tells you where you can go, whether you can go east, west, or north, or south. A lot of the work I did in this CA was on the parser. I have the split function here, which was what we did in class to help split the strings if need be. If they pass in multiple words, then you can split it up word by word. So if they say go to arena, you can get go, you can get to, you can get arena, which helps when you're taking an input. It helps you decide what you're going to do with their input. I added the get input function, which takes in a vector of strings called line and the string word. So I have an iterator here for the vector of strings. That's called iter, and then it goes for line.begin and up until as long as the iterator is not equal to line.end. So that's pretty much just getting between the beginning and the end of the vector of strings. So that would be the first and the last element. And then it increments the iterator. And if the dereferenced iterator is equal to the word that you're looking for that you pass in up here, then you return true because you found it. Otherwise you return false because you didn't find it. You didn't find a keyword such as go, or sorry, you didn't find the word. You didn't find an appropriate word to pass back. Then in the parse function, you utilize the get input function. You take in a string, and then you get line, so you get the entire line. So if it's a long-winded, multiple-worded input from the user, you can still get the entirety of it. So that's why you get line as opposed to, say, just cin. And then this is, so here you would be looking for your keywords such as go or go to, and then what room you want to go to. And then you make a vector of strings called v, and then you split up s, and then it's the size type here, so I equals 0 for the vector of strings. As long as I doesn't equal the size of v, which is the vector up here, then you increment I. So then you keep going, and then you also increment I when you're done. Then you just see out v, will the ith element of v, and then if the ith element of v is equal to go with an uppercase G, or go with all lowercase, or to both uppercase or lowercase, then you increment I, and what should have been there was you get the next element in, which would have been the name of the room, and then you go to that room. And then the get next area function was the last thing I added into the parser. That takes in a vector of strings called reference to a vector of strings called line, and a reference to the world, and that's called world. and then you have a boolean found for if you find the area, and then it's just another iterator here for a vector of strings. I have an iterator called iter, and then once again for the vector you get the beginning element, and you keep going between the iterator equals the beginning element, and then you keep going so long as the iterator is not equal to the end element, and then you increment the iterator. And if the world.findExits, which is in world.cpp, is the dereferenced iterator pointing to that is equal to true, then you found exits, and you found the exit you were looking for, and you can travel to that room. So then here you go world.setCurrentRoom to the dereferenced iterator. So that means you're going to whatever the iterator was pointing to, which should be the name of the room. So you'll set your current room to that room. So that's how you will travel. And then you call the print room function on the room, your current room. So that will print out the description, the name, the exits, etc. And then you return found equals true, which says that you found the room you were looking for. Otherwise, you return found equals false. And then, otherwise, if found is equal to false, then you just see out, sorry, you can't go there, and you loop back around.